financial aid money, this financial aid money you're taking now, you never get back until you finish, like, you're like 30 year, like, job, with financial aid money, you should take out for all your schooling.
No, I'm not.
You pay that by the time you're like, you're 52.
I'm financially disadvantaged, so I can't take financial aid. How can I get this?
No. See, my plus.
All right, it is 9:36 already, so let's go ahead and resume the class. Okay. And I think Hardy came in a little bit late.
Sorry.
Oh, you're lucky. Lucky. I was gonna tell you. I can notice you're here, but.
All right. Let's go ahead and get started again. I think we started on the topic of records already. I just cannot remember exactly where we stopped with records last time. So that's why YouTube is helpful.
Can we go over some more test review?
You guys want more test review?
No.
We can do one more.
Why are you gonna confuse my head with all this other stuff?
All the other stuff like author?
No, not that stuff.
With what stuff?
With like more, like, because you're gonna work forward, right?
Yeah.
I don't want that in there now.
You can block it.
Say no.
Set up your firewall. It's 1 week from today, so you guys still have quite a bit of time to do that, to review for the test. Well, let's do one more question. I can borrow one from another class. Yep.
I got a question about in OpenOffice, when you select multiple columns and resize them all at once, how are you doing that?
How did I do that?
You just select all of them from the top and then double left click on the border of one of them and it
Exactly.
resizes all of them.
It'll fit them all down to the minimum width.
I've done that though.
Or you can go, you can hold shift and click on like column C through E and then just drag it, like select one of the like borders and then just drag it.
I don't know, on mine for some reason, when I select multiple and then try and drag the edge, it doesn't resize all of them. It will just do the rightmost one and just resize that one. Or when I double click, it just resizes one.
Well, let's go ahead and look at one more sample question. This is from my Tuesday, Thursday class, and I set up that class to be a little bit different. So these are still questions that I actually asked in one of the exams, in one of the times that I taught this class. All right, so this is the source code. We have you can see the name of the file is rx7, and then we have fc and fd as the subroutine names for the car buffs. Some of you have no idea what it is. That's fine too.
It's a Mazda with a rotary engine.
Yeah, and then the FC is the second last generation, and FD is the last generation of that car.
Are you looking to purchase one?
No. Why? Do you have one? Do you have one that you're selling?
I have one that I need to get rid of.
Really? Rid of?
Is it
What's
a?
wrong with you?
Would it happen to be a turbocharged white
Oh,
FC?
Supra.
Black, but I just started on.
Uh-huh.
Why do you want to sell it?
So?
Because it can never pass smog. That is why. That's a common problem with the rotary engine. All right, so here's we have a program, and it has more. This is more reinforcement of how to pass by reference. So I think this is a good good one to look at. Just because we need more exposure to passing by reference, and this is a good one. Okay, so we'll go ahead and trace the program. The other side. And I set up some of the columns for you already, not everything, but some of these are already set up. Z is the global variable. Z is a global variable because Z is used outside of the context of the subroutines. And let's start execution on line 14. Line 14 says we want to invoke FD and pass Z as parameter X and pass Z as parameter Y at the same time. So now we have to set up the columns. None of these subroutines is returning any values, so we can use return line number in both cases. On line 14, the return line number is going to be post because there are no additional lines after line 14. Then we need one column per parameter and local variable. FD has x, y, and local variable I. Local variable I starts with a value of unknown, so that's why it's a question mark. And I'll show you guys how to shrink all columns at the same time. I use z to specify parameter x. Z is living in column B, and as a result, parameter x is also known as column B. Yep, go ahead.
Okay, so you said the only global variable we had was z,
That's correct.
right? But yet we said that the local variable was just I. So what are x and y considered?
They are parameters.
They're parameters.
Yes.
Okay.
Yeah, parameters allow the invocation to quote unquote communicate with the subroutine.
Okay.
Yep. And local variables are completely hidden from the invoke statement. There's nothing you can do on the invoke statement other than to just allocate the space for that.
Okay.
And then we have y here. Y is also specified using z, which is living in column B, and as a result, y is also an alias of column B. So now here's the trick to shrink all columns to exactly the width that they need to be, or they require. So you have to hold down the shift key and then click the header of the column, which is in this case is F. So you should see all 4 columns selected in this case. Then you move your mouse cursor to the edge of one of them. It doesn't have to be the last one, it can be the one in the middle. When your cursor becomes a double-sided arrow like this, then you double click, and it should shrink all the columns that you have selected at that point. So don't drag it, just double click it.
Okay, I'll try it again.
If that doesn't work,
any luck.
yeah, if that doesn't work, you can always right click and then select optimal column width, which does exactly the same thing. Sometimes I do that, because I'm not the best, mouse user. Sometimes I don't control the mouse movement as well, especially when I'm double clicking. Okay. Now we continue execution in the subroutine. Subroutine FD starts on line 10. Line 10 is calculating y plus y, and we want to store that value into I. Y is an alias of column B. Column B has a value of 6. 6 plus 6 is 12. We store 12 into I, which is column F.
Did you
Yep.
put 19 instead of 10?
Oh, okay. Off by 1 key. Thank you. Okay, now we move on to line 11. Line 11 is adding 1 to X. X is also known as column B. Column B has a value of 6 at this point. 6 plus 1 is 7. We store the 7 back into X. X is an alias of column B, and column B is now updated to a value of 7. Are we doing okay so far? Yep.
So whenever it says by reference, we're using the AKA, but if it says by value, then you would just enter 6 into Y or X, right?
That is correct.
Okay.
Yep. Because when you pass by value, you're making a copy of whatever you use to specify the parameter. And after the invoke statement, they become completely independent. You can do whatever you want to the parameter. It has no impact whatsoever to whatever you use to pass to that parameter. And then on line 12, we invoke the other subroutine FC. So now we have to set up additional columns. First of all, we have to set up return line number. The return line number in this case is just line 13 because line 13 logically follows line 12 in this case. And then we have to set up 1 column per parameter. We have parameter X as well as parameter Y. The only thing that is confusing here is I use Y of FD to specify X of FC. So that means the X parameter X of FC is actually this one here, which is an alias of column B. In this particular program, it doesn't seem to make any difference because both parameter X and Y of FD,
They both point back to the same column.
exactly, they're both aliases of Z. But this Y is coming from X here.
In a different column, you could create a problem if you didn't.
Well, it's not a problem. It's just the behavior. You just have to be careful which one is passing to which other one.
Okay.
Okay. So now that we have all the columns set up, we can proceed and go into that subroutine. In this case, it's a subroutine FC. The only thing that it does that is useful is on line 4. Line 4 wants to calculate the sum of x and y. X is an alias of column B. And column B, oops, I put in the wrong value here. That's line 4. Okay, column B has a value of 7 at this point, and column B has a value of 7. So we have 7 plus 7 on the right-hand side of the assignment statement. And then on the left-hand side, we have y, which is also known as column B. So column B is now updated to a value of 14. And we're done with this. We go to line 5. Line 5 here looks up return line number so that we know we continue execution on line 13 after this. And then we have no use of these columns anymore. So we have to indicate that these are no longer in use. Then we continue execution on line 13. Line 13 is also just the end of a subroutine, so we look up the return line number to remind us that we have to go back to post. Then we just deallocate all these columns, and we're all done. Now, one thing you can do with this one, if you want to try it out, try out different things, is to change one of these, parameters to say I. Okay, use I to specify y instead of x, and then see what happens. Okay, so that's that one. So one extra, sample question for exam number 2. Now we are going to move on and talk about stuff that we stopped at last time. I thought I had that already popped up somewhere. Okay, so let's go back to 2011 0401 CISP 300. And just go all the way to the end to find out what we were talking about before the end. Oh, we were converting the time from what we normally use to the internal representation in the computer, which is also called the epoch way of computing timestamp. That was the last thing that we did. Okay, great. So this is good. We have already started to talk about records, and this is the first exposure, to records. So what we will talk about today is also related to records, but it is something a little bit different from what we have talked about before. Up to this point, we have always focused on the mechanism of doing things. How do we pass something by reference? How do we pass something by value? How do we work with arrays, and so on and so forth? What I want to kind of focus on, I'm not sure whether I should do that or not. Let me just take a look at this part here. Have we talked about an array of records in this class? No. Okay. Let's go through this stuff first. So that we'll be ready to talk about the other stuff later on. Okay. So in this case, we have an array of records, and this is a binary search algorithm. Yep.
I don't know if it makes because you're using a different class for the Tuesday Thursday class.
Oh, this is Tuesday, Thursday?
Yeah.
Oh, okay. It's the same notes. Both classes use the same notes.
Because when you were saving, I don't know if it saved to our class or.
Oh, OpenOffice is still saving to our folder. I was just using the wrong class, in terms of the links. But they have the same links. Both classes have the same links in terms of the class material. So that part should have been okay too. It's better to just stick with what we have in this class here. And we are still in types and records. So you can see it is the same nodes. Both classes share the same nodes. So let's go ahead and show only this frame. There we go. Okay, this is a fairly long example, so I'm not going to do this one here. You should read it, but I'm going to go through another sample program in the class with trace. Okay, that's the whole point of tracing is not only do we want to look at how the algorithm is specified, we also want to know what happens when you execute the algorithm. So what we'll do is we'll start with a new program. And this time I'll start with something that is a little bit simpler. And we'll just say record, let's say student. Okay. And there are, let's say, 2 items I want to keep track of for each student. The first thing I want to keep track of is the ID of a student, and the other one I want to keep track of is the GPA of a student. Okay. So we have 2 what we call properties or members of a record. Are we doing okay so far? Yep, go ahead.
Is it extremely relevant to put the spaces in between the semicolon?
No, it is just so
You
that
don't,
it
you
is
don't have
more
to
clear.
within code itself.
No, for this class, it's just it's pseudocode, so the syntax is not really that important.
Okay.
As long as I know ID is of the type integer and GPA is of the type number, everything is good.
Okay.
Yep. In some language, they spell out like ID as integer and so on. That's just as good in this class. If you prefer to use the C notation, you say int ID, which is actually saying the same thing. Yep. Okay, so now what we want to do is to find out, how can we deal with an array of student records. First, let us define a stub function or stub subroutines. Define stub. And in here, we have let's say we have a local variable. The local variable is A, and what A is an array of, say, 3 student records. So this is how we specify that A is a local variable, and it is an array of 3 student records. And then next, we'll go ahead and read something into this. Okay, so or we can just go ahead and initialize the whole thing. It doesn't matter, either way it's fine. So I'll just go ahead and initialize everything by hand. So I will have to initialize each thing one by one. So a bracket 0.id will be initialized to 5, 6, whatever numbers. I don't really care about that part. GPA is 3, and then a bracket 1.id is that, and then the GPA is 2.5, and then the last one has an ID of that, and then the GPA is 4. Okay. So these 6 lines are really doing nothing except to initialize the array so that we can do whatever we need to do with the next subroutine. The next subroutine is going to figure out what is the average GPA of the entire class. So here we'll say print invoke average GPA, and that requires one single parameter. I need to use my local variable A to specify the parameter, which I will just call X in the subroutine. And define sub. So that ends the subroutine that I call stub. And now we have to define the other subroutine, which is average GPA. Define sub average GPA. And over here we have passing by reference. We have X, which is a parameter that is passed by reference. And we'll only say that this is an array of student, because we don't know exactly how many students, because that part is controlled by the caller. Okay, whoever is invoking the subroutine can sometimes give me an array of 3 students, and other times give me an array of 50 students. I don't know exactly how many students until I actually run the code in the subroutine itself. I will need something else in this particular subroutine. I need a local variable, which is the mean of the whole thing. So I'll say mean is a number, because I have to calculate the mean or the average of the GPAs, and that's what I would use to return to. I also need another local variable I, which is an integer, so I can go through the entire array so I can sum up all the GPAs. The code of this subroutine is not really that difficult. I initialize I to 0, and I say as long as I is less than bar x bar, do the following. Whatever I do in the loop is just mean gets mean plus x bracket I dot GPA. I gets I plus 1, and while, and then forgot to initialize mean first, so we have to insert a row, and then say the mean, MEAN, start with the value of 0. And when everything is done, I have to return the average, and that's the end of this subroutine. In the main program part, the only thing I have to do is to invoke the stub subroutine. And once we fix the indentation, we'll be ready to trace it. Go. Have the line numbers. All right, so let's go ahead and see what happens when we trace this particular subroutine or this particular pseudocode. There you go. On sheet 2, we have to we need one column for comments because we definitely have conditions to evaluate, and we also have a print statement. And we have line number. The program does not have any global variables, so the precondition is really easy to state. The first line and the only line outside of the definition of a subroutine is on line 27, so we start with that. Line 27 is invoking stub. If you look up stub, stub itself does not return a value, so we can just go ahead and use return line number for simplicity. There's nothing after line 27, so we'll just say post. And then we also need to make sure that we pass the parameters correctly to stub. Stub does not require any parameters, so there's nothing to pass in this case. What it does have is a local variable. The local variable in this case is an array, but the array is not an array of numbers, it is an array of student records. So as a result, this is what we need to do. We'll say that this is array A. Array A is going to take up 6 columns. 1, 2, 3, 4, 5, 6. It's going to take up 6 columns because it has 3 elements. Each element takes up 2 columns. Like that. Now let's see what happens here. This is the first element. This is the second element. And here we have the last and third element. Within each, what is exactly one element of array A? What is the type of an element of array A? If you look at line 6 of the source code, what is one element of this array? It's a student, okay? And when you look up the definition of a student record, what components or what members does it have? It has 2 members. It has a member called ID, which is an integer. It has another member which is called GPA, which is a number. So that's why ID takes up its own column. GPA takes up its own column for the first element. The second element, exactly the same thing. The third element, exactly the same thing. And this is why the entire array will take up 6 columns altogether. Like so. Do we have any questions at this point of why we set up local variable A this way? Now, because it is a local variable, everything inside it must start with some unknown value. So that means we have 6 question marks in this case, because every single item inside this array should start with some unknown value to begin with. Are we doing okay so far with this picture? Because we are looking at the implementation of an array of records, not just one, but we have an array of these things. After we set this up, we can go ahead and execute line 7 all the way up to line 12. I'm not going to execute these lines individually because they are really kind of boring to track if I execute those individually. So I'll just go ahead and, oh great, it is not a date. Line 7 to line 12. There we go. Okay. We'll just go ahead and fill in those values. 572. It's going to complain at some point not having enough space to display the numbers. 1733, 2.5, 8127. 4. Okay, just have to change the width a little bit so everything shows. There we go. All right. So line 7 to line 12 are fairly boring because I'm just initializing each individual column within those lines. On line 13, we have an invocation of average GPA, and then we want to print the value returned by average GPA. So now is a good time to set up, the columns for this new invocation of average GPA. Well, that's going to be a little bit difficult because now the screen has to split big time. Let me see what is the best way to do this. How about a new window? So I'm opening up a new window just to display the content in the array. And we'll stash it down here. And then we'll shrink this one so that it shows the array, the column reference. And then we'll keep tracing over here, but this time I can hide everything up to this point. There we go.
You got it.
Almost. There we go. Now we have it. Okay. All right, we are executing line 13 right now. Line 13 is invoking average GPA before it can print anything. So we have to invoke average GPA first. Average GPA is going to return a value. So we know that this time we do have to use return info because there are additional things we have to do when we come back to line 13, which is just printing the value that is returned. But when you invoke average GPA, you also have to reserve and initialize the columns for the parameter, which is x, as well as all the local variables, which is mean and also I. So in this case, we need one column for x, one column for mean, and one column for I and mean are easy because they are local variables. We don't even know what is supposed to be initial. They must be initialized inside a subroutine. X, on the other hand, is passed by reference. I am using array A to pass by reference to X, so that means, okay, I'm losing, okay, just hold on a second here, I'm changing a little bit of how windows are specified. I can use mouse over to select. So this way I can do the scrolling a little bit easier. Okay, so when you look into X, I use array A to specify parameter X. So that means X is an alias of something. It's an alias of which column to which column. Column D to column I. Okay, because array A is going from column D to column I, and I'm using array A to specify parameter X, and as a result, X as a parameter is an alias of column D to column I. Are we doing okay so far when we pass an array of records by reference to a subroutine? Have we changed the meaning of passing by reference? No. So now we move on to line 14. Oops, no, we go into the subroutine because we set up everything to go into the subroutine. So now we go into the subroutine starting on line 19. Here's line 19. Line 19 doesn't do anything that particularly interesting. It's just initializing I to 0. And then we have line 20 initializing mean to 0. And then we have line 21, which is the conditional part of a loop. I is less than bar, x bar is, well, let's figure it out. What is x? X is an alias of column D to column I. Column D to column I is here. It is an array of 3 items. It's an array of 3 student records. So bar x bar is 3, not 6. Okay, because we are not counting the number of columns. We are counting the number of elements. And each element takes up 2 columns, and that's why we only have 3 elements, even though the array takes up 6 columns. I, on the other hand, has a value of 0. Is 0 less than 3? It is. So the condition is true. We go into the loop, we go to line 22. Line 22 is just adding the GPA of x bracket I to mean itself. Well, let's look at what is I. I is 0 at this point. X bracket I is basically A bracket I, which is A bracket 0. A bracket 0 has a GPA member. The GPA member has a value of 3. So this time we're adding 0 plus 3, which is 3. And we use that to update mean. Mean is now 3 here. Okay. Are there any questions? There's a bad flaw of this program. It doesn't actually calculate the mean. What is it calculating? It's calculating the total. So I have to fix the program later when we get to line 25. It's an easy fix. It's just that something that I forgot to do is to divide it by the number of elements. But we can do that later. Moving on to line 23, we add 1 to I. I goes from 0 to 1. And then we go back to the beginning, which is line 21. I is 1, bar x bar is 3, 1 is less than 3 is true. We go to line 22 again. On line 22, we have to first access x bracket I. X is an alias of column D to column I, which is array A. And I, at this point, has a value of 1. So effectively, we are accessing A bracket 1. A bracket 1 has 2 members. We are only interested in the member GPA, which has a value of 2.5. So this time we are basically adding 2.5 to 3 because mean already has a value of 3. And then that's 5.5, and then we store that back into mean. And that's why mean at this point will be updated to a value of 5.5. Are we still doing okay so far? Okay. Now we move on to line 23, which is just adding 1 to I. I goes from 1 to 2. Then we go back to the beginning, which is line 21. I is 2. Bar x bar is 3, 2 is less than 3 is true. We go to line 22. Line 22 is computing the sum of mean and x bracket I dot GPA. Mean has a value of 5.5 at this point. I has a value of 2. X, on the other hand, is an alias of column D to column I, which is effectively array A. So we are accessing array A, element 2, and also we are only focusing on GPA as a member of that, which has a value of 4. So now we're adding 4 to 5.5, it becomes 9.5, and then we store the result back into mean. So now mean is updated to a value of 9.5. Are we doing okay so far with this? Okay. And then we go to line 23, we add 1 to I goes from 2 to 3. We go back to line 21, we compute I is less than bar A bar. It is now false because 3 is less than 3 is false. We get out of the loop, and this is where I need to change the source code because I forgot to divide the whole thing by bar x bar. So now it is doing what it is supposed to. Before it was not, now it is. So after we get out of the loop, we go to line 25. Line 25, wants to compute mean divided by x first, and then we want to, and then we execute the return statement. The return statement, when you execute the return statement, all you have to do is to copy and paste the return info cell, and then change the question mark to whatever we are supposed to return. Well, let's try to figure out what we are supposed to return. 9.5 divided by 3 is 3.17. So we'll just replace the question mark with 3.17, which is just an approximation of the actual number. Okay, are we doing okay so far? Yes. In a way, I'm kind of glad to see you guys bored. Because when you guys are bored, it means you already know how to do something like this.
No, we're trying not to learn it so that we can keep all the test information.
Just put it in a Ziploc. It'll be okay. Put it in a Ziploc, throw it into the freezer. And then on next Thursday, you take it out and just thaw it. Okay, so on line 25 is done. We go to line 26. And on line 26, we have to first remind ourselves where to go back to. According to return info, we have to return to line 13. And this is line 13 when we get back to it. And after that, we have no use of these 4 columns anymore. So we copy and paste the header of the columns. And Okay, I think I got. No, this is right. Yep, that's right. Okay, so we have Control 1, Shift S. So now we're back to line 13. Line 13, only has one thing left to do, which is printing out the value, the return value. So we print the value of 3.17 to the screen, and after line 13, we get to. After line 13, we get to the end of the subroutine, which is line 14. And on this line 14, we have to look up the return value or return line number. It tells me to go back to post. So here we are supposed to go back to post. And then we have no use of these columns anymore. So it's time to indicate that all these columns, 7 of them, are now deallocated. So Control A, like that. And when we do go back to post, that means we're at the end of the pseudocode to trace, and we're all done. Any questions about this one? No questions? That was quick. So let's go and save this file to today's folder. And I'll just call this average GPA. There we go. Right. So now we have seen, how to deal with records and how to deal with an array of records. Now, records, they're very useful because they allow you to basically group an arbitrary number of things that do not have the same type together because they are related in some other way. In other words, it makes it possible to make forms. Okay. Before we have records, we can only have individual slips of paper. Okay, here's your name, first name, here's your last name, here's your address, state, zip code, and whatnot. Now we can integrate everything into a single form. So on the form, you have a place for the first name, last name, middle initial, and then you have another line for your phone number, another line for your address, and so on and so forth. So we can now organize things in a very neat way. But then there are good ways of using records and bad ways of using records. Okay, so before we, go ahead.
So when you say records, are you referring to like the .gpa?
No, the record in this case is the name of the template, which is student.
Okay.
Yeah, when I refer to a record, it refers to the cookie cutter, and whatever you use the cookie cutter to cut out, because they are our variables or parameters or local variables. Okay. Mm-hmm. Okay, so let's go ahead and take a look at another sample program, and this one is going to be not very complicated. Let's just say that I want to be able to represent a point in 2 dimensions. Okay, in a 2D space, I want to be able to specify a point. Okay. So what we'll do is we'll define a record type just for that purpose. We can call it coordinate. We can call it point. Let's just call that point, okay, point in 2D. What is the most intuitive way to represent a point in 2-dimensional space? X and Y, okay? Is it called the Cartesian cadastral coordinate? Cartesian?
Cartesian. Yeah.
Okay, I watched too much Star Trek. Cardassian, right? Cardassian, is a species in Deep Space Nine. It's funny how I can remember those things and not really the useful things that I'm supposed to remember.
You saw that coming.
Okay, so we will represent a coordinate using x, which is an integer. Basically it's just a pixel number in the x coordinate, and the y, which is the same thing for the y-axis. And record. Okay, that's not hard to do. Pretty easy. Okay. Now let's go ahead and I'll define a few 2 seemingly useless subroutines. Okay. It seems like, Tech, why do you waste time doing this? Okay. So I'll go ahead and waste my time to define these subroutines. The first one is set point. Okay. All it does is to pass by reference a single point, which I will call my parameter p, which is a point. And it will also require two other parameters, which is passed by value x, which is an integer, passed by value y, which is an integer. And the only thing that it will do inside this subroutine is to initialize point. So p.x gets the value of parameter x, p.y gets the value of parameter y, and define sub. Let's take a look at this subroutine here, because I think there may be some confusion about these two lines. How do we know which x we are talking about, and how do we know which y we are talking about? And by the way, is it even permissible to use x and y as names of parameters now that we have x and y as names of members inside a record? The answer is yes, it is okay to do that. There's no problem.
Because you said so?
Hmm?
Because you said so?
Nope. Nope. Everything in this class is because the compiler said so in cisp300. So I have good excuses, and say, nope, I didn't say it. It's the compiler. Well, I did write compilers in my past life, so I can understand from that perspective as well. Okay, so let's take a look at the left-hand side first. Okay, p.x. Okay, what is p in this case? P is a parameter. Okay, and it has a type of point. Very good. So when we say p.x, it is basically the dot is apostrophe s. So this is basically saying refer to member x of p. Is that clear what we are talking about? Pretty clear. How about the right-hand side? It is x all by itself. Now when x is all by itself, it cannot be referring to a member of something, because x is just the name of another parameter x. So this is true for all programming languages. You can reuse the name of a member somewhere else in a program, because the name as a member is very context-based, and you can only refer to the name as a member when it is the right context as the name of a member. Yep.
So does that x refer to the by value x?
Yes.
Or
By value x.
and it doesn't refer to the x integer up top.
That is correct, because in order to get to this one here, you have to have x to be appearing on the other side of the dot. It has to be on the right-hand side of a dot to make sense.
Okay.
Yep. Okay, so, but this subroutine doesn't seem to be very useful, does it? Because all it does is to initialize a point based on the parameters x and y. We might as well just use two assignment statements to get it done instead of invoking this subroutine. Okay, so this doesn't seem to be very useful. And let me give you two other subroutines that are seemingly pointless. Okay, no pun intended. So the other one is called get point x. Get the x component of a point. Well, this is just a waste of time. I mean, we pass it a parameter which is of the point type, and all we're going to do is to return p.x, and that's it. I mean, why do we do this? I mean, and there's another one called get point y. Same thing, pass by reference p, which is a point, and return p.y, and define sub. So I'm wasting my time here to do all of these little things that do not seem to be useful at all. Okay. All right, so let's go ahead and define the stub subroutine just to show how to use these things and why someone may think that, hey, why do we even bother to do something like this? So here's my stub subroutine, and I'll have two local variables. Let's say we have p1 as a point, and let's say we have p2 as another point. So p1 and p2 are local variables, and each one is a point. For p1, I will invoke the subroutines to do everything. So for p1, I'll just say invoke set point, and use p1 to specify parameter p, and I'll just say that this is the one of the points that I want to represent. I don't care. 4 goes to x and 5 goes to y. And that's fine. Okay. So that's one way to initialize a point local variable. With P2, I would use another approach. I would say, oh, we'll just directly access the x member of P2 and have it into initialize to, let's say that these 2 points will be referring to exactly the same coordinate. Okay, so this way we have a very clear comparison of the approaches. Okay. Is everything okay up to this point? The meaning of the subroutines and also the stub subroutine? Yep, go ahead.
Just a quick question, what is P2?
A P2 is just another variable. It's just another local variable, which is of the point type.
Oh, okay.
Yep. So I just want to use another variable to illustrate the other way of accomplishing exactly the same thing. Okay, so what do you think? I mean, let me do one more thing here. Okay, so let's see. We insert a row here, and we insert a row here. Because I want to print out the x coordinate of P1, and I want to print out the same thing for P2. So over here, I would say print invoke get point x, and then use P1 to specify P, just to print out the x coordinate of the first point P1. And over here, I would say, but that was dumb. I mean, that's just way too much work. We'll use P2.x and get to the same thing. Okay, so now we have a very clear comparison. Line 23 is basically doing the same thing as line 25 and line 26, just on different variables. Is that okay so far? No? They're not doing the same thing?
No, they may be. I just can't tell.
You cannot tell. Okay. Shall we trace it so that we can tell? Okay, let's go ahead and trace it. So in the main portion of this program, we just invoke stub, so we know what the program does. And we have line numbers. The line numbers are completely redundant unless you print it out, because otherwise the row numbers will indicate the line numbers already. Okay, so here we go. Let's trace. Let's save it first before I forget. I call this ADT1, okay, which is a strange name for a subroutine. It doesn't seem to have anything to do with this subroutine at all. We do have print, so we need comments, and then we have line number, but there are no global variables. And then we start execution on line 29. On line 29, we invoke stub, so that means we have to allocate the space for both of these points. So we say, we have a return line number first. We return line number. It's going to be post because there's nothing after line 29. And then we have to set up the local variables. One is P1 and one is P2. Now each one is a point, and one point takes up 2 columns. And that's because when you look up the definition of a point, it has 2 members. Each member will take up 1 column. So P1 has a member X, has a member Y. P2 also has a member X, also has a member Y. This is taking up way too much space, so we can compact it just a little bit. Now we can see everything.
Okay.
Yep.
It looks like you're trying to draw a line
Draw a line.
rather than, because you were talking about just finding a point, but now you're going to find 2 points in a flat plane.
No, I'm not drawing anything. I'm just specifying locations of points.
Okay.
Yeah, but I'm not really doing anything with it. Not at this point anyway.
Okay.
Okay. And now we can move on. Once all the columns are set up, we can go into the subroutine, which is stub. Stub, starts with line 23. Line 23 is invoking set point as a subroutine, and it is just using P1 to specify P, 4 to specify X, 5 to specify Y, and so on. So what we'll do is we'll go ahead and invoke that subroutine, and it does not return a value. That means we can use return line number again. The line that is logically following line 23 is line 24. And then we just have to set up a parameter P. Parameter P is passed by reference, and we use P1 to specify that. So that means P as a parameter passed by reference is an alias of column D to column E in this case, because those 2 columns are occupied by local variable P1, and that's what we use to specify parameter P. And then we have 2 more parameters to take care of. One is parameter X and one is parameter Y. But those are passed by value, which means whatever we specify here in the invoke statement is whatever it ends up with. So x ends up with a value of 4, y ends up with a value of 5, and now we are all done with setting up the columns before we go into the subroutine of set point. Set point really does not do anything that's particularly fun because all we do in that particular subroutine is starting on line 9. Line 9, oops, wrong place. Line 9 is just putting parameter x into p dot x. Okay, parameter x has a value of 4. P is an alias of column D to column E, and of column D and column E, the x component or the member x is column D, so that's why column D is now updated to a value of 4. Line 10 is doing the same thing with y, so that's why column E ends up with a value of 5. Are we doing okay so far with this? Question?
I think you messed up with the line. The correct line is to the bottom of the line.
Oh, I see. Oh, the line number is wrong.
Yeah.
Okay, copy, cut, paste. There we go. Thank you. We can shrink this one too. Okay. So those two are not really doing anything particularly interesting, and we are already at the end of the subroutine set point. So at the end of the subroutine set point, we remind ourselves where to continue execution, which is line 24. Then we have no use of these columns anymore. So we have to indicate that these columns are now deallocated. Like so. And continue execution on line 24. Line 24 is printing the X member of P1, so which is done by another subroutine invocation. But this time it is returning a value, so you have to use return info instead of return line number. But it's not a big deal. We just have to remember that we are supposed to come back to line 24 and finish up with the printing part. That's all we have to do. Let's do it this way. And we also have to pass the parameter P1, or parameter, we have to pass local variable P1 to parameter P. So they end up exactly the same way as last time, like so. And we have to indicate this is for parameter P. In other words, we are reallocating column H and column I when we execute line 24 the first time. Once we set up the columns, we are now ready to go into the subroutine. The subroutine starts over here, so we are now ready to go to line 14. Is line 14, or the execution of line 14, which goes to this cell here. That doesn't help. Okay, on line 14, we are just returning p.x. What is p? P is an alias of column D to column E. Column D to column E is P1, and we are only interested in the member called X of those two columns. The member that is called X is column D, which currently has a value of 4. So that means we copy and paste the return info cell, change the question mark to a value of 4, and we are done with the return statement. After line 14, we move on to line 15. So on line 15, we have to remind ourselves that we have to continue execution on line 24. And line 24 looks like this at this point. And then we have to deallocate those two columns, like that. When we continue execution on line 24 already knows that it's supposed to print the value of 4. Yep.
You have a couple more columns you could deallocate.
I think that's it, because we don't use a column J or K when we invoke get
Oh,
point X.
no, never mind. I see what you did.
Okay. So on line 24, when we execute it, we have to print out the value of 4, and we are done with line 24. Then we move on to line 25, line 26, and line 27. Those are much easier because they don't really invoke any subroutines. So line 25 is putting a 4 into member X of P2. So P2, member X is column F, that now gets a value of 4. Line 26 is doing the same thing to the y member. So y gets a value of 5. And on line 27, we are just printing the value of p2.x. p2 is over here. The x component is column F, which has a value of 4. So now we print 4 as well here. And then we are done with stub. We are at line 28 of stub. We have to look up return line number to remember to go back to post after this. And then it's time to just deallocate the 5 columns that we allocated earlier for this. And we are done with the execution of the subroutine. Are we doing okay so far with this? So after the execution of the subroutine, then we can see that in the original code, this line 23, is doing nothing more than just initializing P1. So the P1.x is 4, P1.y is 5, which is the same thing as on line 25 and line 26 of what we do to P2. Okay? Is everybody now convinced that line 23, what we do to P1, is exactly what line 25 and line 26 do to P2? Okay? And it's the same thing with 24. It is just a more complicated way to get the same thing that we did on line 27. Right? So the question now is, why do we bother with these stupid subroutines, set point, get point x, get point y, when we can just directly access the member of x and y of P2 like we do on line 25 to line 27 of the stub subroutine? That's the question. Okay? We don't do something like this for no reason at all. So for the time being, let's just change our context again to something that seemingly has nothing to do with programming at all. Let's look at televisions, okay, TVs. I think at this point I can still assume most people in this class know what is a CRT, a tube-based television. Okay, it's conceivable that in 10 years, okay, if I teach here for 10 more years, I can mention CRT or tube-based television, and no one understands what is a tube. And by the way, why is YouTube called YouTube? Where's the tube part of YouTube, right? Because we don't use tubes anymore. So I'll just kind of briefly explain the mechanism of a tube or a CRT and how you can actually see an image on the screen on the CRT. This is a cross-section of a CRT or a cathode ray tube. Okay, that's the full name of a CRT. It has what we call an electron gun at this part here, which is a high voltage device. Basically what it has is a heating element, and also there's a huge negative charge on this part here. So it's warm, it's hot, actually it's hot, and it has a negative charge to this part here. There's also a gate about here that has a very positive charge to it. And the whole thing inside the tube is vacuum. And that's why CRTs have really thick glass, because you have the entire atmosphere pressure pressing on the whole thing, and it's vacuuming in the inside.
Well, that's the problem that they had when that's why they didn't used to make the flat screens, because they had to bow it to put up with the pressure.
To strengthen it, right? Yep. So what happens is because it's vacuum, and this is a negative charge, this is a positive charge, and this part is hot. So a lot of electrons are ready to go. Okay, they're basically ready to leave the filament and go to wherever the positive charge is. That's the behavior of an electron, is they don't like to stay where the negative charge is, and they want to go where the positive charge is. So they want to go this way. Now when they go this way, because there's a gate here, they usually don't end up landing on it. They usually end up passing through it at a certain speed. The larger the difference between these voltages, the faster the electron will flow. So after it gets out to here, it becomes an electron that is actually shooting out of the electron gun. Then you have coils. Okay, you have magnetic coils. One is like this, and the other one is like this. Because any electron or any charge in motion can be deflected by a magnetic field. So by changing the magnetic field here, and also the other one that you cannot see that is wound this way, you can control the direction of the electron. You can make it go up and also to the left or to the right. Okay, and that electron will end up, somewhere on the screen, on the inside part of the screen. And there's some sort of a phosphorus compound here that is luminescent, that can luminescent, photoluminescent. So basically, when the electron hits this particular surface, it will emit light on the other side, and that's how you can see visible light, even though internal to the tube it is all just fast electrons sweeping the whole thing. Okay, so this is the basic explanation of how a television works when we have tubes. Okay, now let me ask you a question. In the good old days when we have televisions like that and they are this deep, even though it's a 26-inch TV, when you want to adjust the brightness of your TV, do you take the case off the TV, go to the circuit board with a screwdriver to try to tweak the voltage between this point and this point, and hope that you don't get zapped in the process? No?
Not unless you're an idiot.
So what do you do to change the contrast of your screen?
You push the button up or down, brightness up or down.
You use something like this, right? I mean, you just go, okay, where's my on-screen menu? Oh, right here. And, brightness. Oh, easy. I can just change the brightness up and the brightness down. And there's no way I can get zapped, because I'm not even touching the television, right?
There was a dial on the really old TVs.
Yeah, there's a dial, on some of the TVs too. Yep, that's correct.
Didn't work. It went darker.
Well, that's because it went to sleep. I did not break it. You guys are witness. I did not break anything today. Not yet. Okay, so that's how a television works when we use tubes. Okay, now, later on we have LCD TVs. How does LCD work? Liquid crystal display. How does that work? Well, we have a light source. Okay, the light source itself is a big story because we can either use fluorescent light in the past, or now we have LEDs, white LEDs, as the light source of monitors. But nonetheless, we let's just say that we have a light source of some kind. So this light will first pass through a what we call a polarizer. Okay, polarizer. A polarizer, when light comes out from a light source, it can basically oscillate, on different axes. And a polarizer is basically just saying, I will only let, light that are oscillating to a particular axis through. Anything that is oscillating in a different axis will be blocked. Okay, so it's not really quite, so black and white, but it is close enough. So we'll just let, some particular light ray in a right, oscillation orientation to pass through. The other ones will be stopped right here already. So this light that is passing through will have to go through another thing. Okay, this other thing, has basically electrode, basically very very thin metals that is actually printed on glass that you cannot see, because when you make really really thin, gold plates, it can be transparent, but it still conducts electricity. Okay, so this is your liquid crystal thing. Liquid crystal. Okay. Now with liquid crystal, it's kind of interesting because normally the crystals are random. They come in all sorts of orientation. So what happens is, when it is in a random orientation, it will just block some of the light that is passing through, but it will still let some through. So some of these lights will be able to pass through, and this is what you see as a white pixel. Okay, so a white pixel is what you see when some light is blocked by the polarizer, but whatever you block using the liquid crystal is just random, and you can still see some light passing through. So this is why an LCD device is actually very very inefficient, because of all the lights coming from the light source. Even on a white pixel, you're only looking at the most about 10% of what you see or what the light source is generating. The other 90%, they are blocked somewhere in the path. Okay, and that's why it is inefficient, because what you see on a regular LCD screen, I cannot show you here, or here. This is fine. I can show you this part here. So whatever you see is white on the screen is actually only about 1/10 of the light intensity of the actual backlight. And that's why when you use a laptop computer, most of the energy is actually wasted on the backlight of the LCD and not on anything else. Your processor can clock down and consume little electricity. Your hard drive can spin down and consume little electricity, but the backlight is the big hog of power. Okay. Now, when you apply a certain voltage across these two plates, a positive and a negative, then the crystal will align. Okay, this crystal will align in a certain way. When the crystals align in a certain way, guess what? Whatever is left of these rays, all of those will be blocked. So now you see a dark pixel. Okay? So to control the contrast between black and white, you basically have to control the voltage across these two plates. That will control how dark a dark pixel is. To control the brightness, you have to control the backlight light source here to crank it up to make it brighter, and you want to basically reduce the current passing through the LED to reduce the light intensity on the backlight. So once again, let me ask you a question. When you want to control the contrast or the brightness of an LCD screen, do you have to open up the back of this thing here, go to a particular place using a screwdriver to tweak the voltage going through, the current going through the LED, or the bias voltage on the LCD device itself?
No.
No. What do?
Get the remote.
Get the remote. Go to the on-screen menu and just press the buttons, right? And once again, this is always the right time. The timing is just perfect. Yep. Okay. Excellent. Now, this particular projector does not use LCD technology. It does not use CRT technology. It uses DLP technology, or digital light processing technology, which is also a very fascinating technology. It relies on the silicon die, and on the silicon die, it has a lot of micro mirror surfaces. And by changing the angle of the mirror, it can change the intensity of that particular pixel just by changing the mirror. And this is done by the what is the name of that effect? I cannot remember the name of the effect. But when you apply voltage on crystal, on silicon, you can bend the shape of crystal when you apply the voltage. And that's how it is done with a DLP. So yet another type of technology. And the backlight of this thing can be high pressure. Is it high pressure mercury with some? And then these days, I think more and more people are moving on to LEDs. But regardless of the technology, this works, right? Just press the menu key, and now I can adjust the contrast, regardless of the technology that is being used inside that box. I mean, for all we know, there could be little elves, actually, painting stuff on the screen. I don't care. If my remote control works, I'm good. Okay? So now, how does that have anything, if anything, to do with this? It is abstraction. Okay? What is abstraction? ABSTRACTION. Abstraction. What is to abstract? What is abstract? Okay, let's compare. Let's see. Paintings. Does anyone know who is Monet?
Monet. So it's
Okay.
abstract is like bunch of little dots, but then your brain puts it together into one. So it's individual pictures.
How do you spell Monet?
M-O-N-E-T.
M-O-N-E-T.
He's an impressionist.
Yeah,
He's
but-
not an abstract artist.
Okay, but for the purpose of our discussion, this is quote unquote abstract. Okay, and I can explain why. From my perspective, this is abstract. So this is a typical painting of Monet. My sister really likes Monet painting. Me, on the other hand, is a big fan of Ansel Adams. Okay, so let's look up Ansel.
Are you serious? Oh, Ansel Adams. Okay.
So let's look up Ansel Adams for some of his pictures, and then we'll pick one that is representative of what I want to get across, the point that I want to get across. Let's pick this one. some of his Yosemite ones, are more representative of what I want to, the point I want to show.
Antique
This is a
ones.
good one.
There you go.
This is a good one. This is a great one. Okay, so we have a picture of the half dome. Is that the half dome here, or is that the other one? Okay, but if you my flash drive is falling asleep. Okay, so how would you compare this picture versus this picture here? Not the scenery that is trying to depict, but the style. In terms of details, which one has more details? This one has far more details, and this one does not have a lot of details. You can still kind of make up, what it is painting. It's a field with flowers, with trees, the sky, clouds, and stuff like that. Yep.
So that's more of like our brains filling in the blanks of what it should be.
Right.
Whereas the other one is just there for us.
The other one, has all the details, preserved, and this one only has, it has enough for you to know what it is, but not really, every single pixel is preserved. Not every leaf is drawn on the tree. Not every single, blade of grass is represented, and so on and so forth.
But even an analog picture would be more detailed than that Ansel Adams digital copy of it.
Correct. Yes. So abstraction is basically, the loss of details. Okay. This is by comparison more abstract than this, because Monet's painting is losing some of the details. Some of the detail that is not important is lost. Okay. Now, when we go back to our spreadsheet, what kind of details are we talking about here? Well, the detail is how the record is defined. Okay. When you look at line 23 and line 24, is there anywhere within these two lines that tells me that a P1, P1 as a variable, has a member called X and a member called Y? No, it was never mentioned. Okay, I'm just using a subroutine to initialize a point, but I'm using the XY coordinate system to initialize it. But it doesn't say anything about how a point is actually represented. On line 24, I'm just asking a subroutine to return the X coordinate of a point, but it never mentions anything about how a point is represented, right? So internally, I can use something that is completely different from what we used earlier to represent a point, but the subroutine is one layer of abstraction that hides that detail from us. Okay, so we don't actually need to know how it is all implemented at the lowest level. When you look at line 24 to line 27, line 25 to line 27, they are very explicit in terms of which part of variable P2 are we accessing. We're accessing the member X, we're accessing the member Y, we're accessing a member X again. Okay, so why do we care? They do exactly the same thing, so one way is just as good as the other one. Well, let's find out what happens when my boss tells me, but Tech, we have to change the way everything is implemented. Okay, why? Well, let's take a look. So I will copy and paste this into let's say sheet 3. And here we'll present an alternative. Because my boss says, well, Tech, this XY representation of a point works really good with a raster-based device. A raster-based device is like a digital camera where, pixels are actually represented in an XY fashion. But that's not always, the best representation of a point. Okay, so to show you that point, I will give you another web page, which has to do with Pac-Man and bicycle. Okay, things that are seemingly totally unrelated, right? Why would I mention Pac-Man and bicycle in a programming class? It's like totally irrelevant concepts. But this is cool. That's partially why, and that's enough reason why I want to present it. Okay, let me turn off the the light here so you can see what it is. Okay, so we have Pac-Man chasing after a ghost. Okay, well, big deal. I can do this in GIMP or Photoshop in 20 seconds. Well, but look at how it is created, how these images are created. If you look at the background, I know it's kind of faint. There's not enough contrast. That's a bicycle, upside down. Can you guys see that?
Oh, yeah.
Okay, I think the bicycle is upside down. Here's the crank. This is the chain, for the rear wheel. And this is the front wheel. This is the fork of the front wheel. This is the handlebar. There's the bike seat. Okay, so somebody flipped a bicycle upside down so it can rest on the ground, on the floor, and spin the wheel really, really fast in order to create, these images. What happens is, you can install what they call a spoke light, onto the spokes of these bicycle wheels. And as the spoke rotates, you can control the LEDs on the spoke light to turn on and off. If you have precise control over the on and off timing of the LEDs, because of the persistence of vision in our eyes, you can actually paint pictures using that technique. And that's exactly how it is done. Somebody used this technique to paint the ghost and also Pac-Man on the bicycle. Okay, as the wheel of the bicycle rotates, it creates these images. Now, what does that have anything to do with our example at this point? Well, when you want to specify a pixel to be on and off, kind of like this here, would you use X and Y? That's not a really good coordinate system anymore, because in this case, you want to use the angle and also the radius to specify a dot. Okay, so my boss says, Tech, we have to change the program so that it will be more efficient when we want to specify which dot to light up and which dot to turn off when we have an application like this. Okay, and I said, hey, no problem, boss, I can do this because I can just change the representation of a point so that instead of x, y, now I have A as an angle, which is going to be just a number, and I will have R, which is a radius. Okay. R is a radius, which is also going to be a number. Well, I guess this one can be an integer too. The other one can also be an integer depending on how I measure angle, because I can always break up a revolution into 400 steps. If I did that, then it's just an integer. But the representation is now different. Okay, so let's see how much I have to change in this program in order to accommodate this new representation of how I specify a point. Okay. When I use set point here, and I want to keep using x, y to set a point, I obviously have to change line 9 and line 10. Because if I am given x and y, and I want to set the angle and the r, I would have to do some tricks in trigonometry to get this done. Because the angle is going to be, is it arctangent of x divided by y divided by x. Let's see. X divided by y. Okay, and the radius is going to be the square root of x times x plus y times y. Right? It's the square root of the square of the two lines. Then you get the exactly. So I do have to make some changes. When I want to get the x component back when a point is represented in angle and radius, I have to do something here because I have to say, okay, this is p dot r, which is the radius, times, let's see, this is x, so that's the cosine of p dot a. Okay, so I have to adjust my calculations accordingly. The other one is going to be p dot r times the sine of the angle of that point. Are we doing okay so far? This is not a trick class. So if you don't understand the math behind this, don't worry too much about it. No, I take it back. Worry about it because these are fairly basic math. Yes?
Isn't it the arctangent of y over x?
Arctangent of Which one?
Yeah, sine over cosine.
This one?
Yeah.
Yeah, tangent is sine over cosine.
Okay.
Yeah.
So that would be y divided by x. Now obviously I'm missing a few logic here because what if x is 0? Then you have to kind of flip it around and do some other tricks with symmetry. But let's just say that we are not too worried about that part. Okay, so I just want to illustrate the point that I can change the coordinate system, and then I can change the subroutines, set point, get point x, and get point y accordingly to accommodate those changes. Now let's go to stub here. Okay, let's focus on stub. Once I make changes to set point and get point x, do I have to do anything about line 25 and line 23 and line 24? Nope, they work exactly the same as before, don't they? Is that right? What about line 25 to line 27? Will they continue to work? They don't work anymore because P2 does not have the x or the y members anymore. They have the r and the a, the radius and the angle. Okay. Okay. But this is easy. We can just apply the same changes that we apply to those two subroutines to line 25 to line 27, and we're done. What if you have tens of thousands of lines, like line 25 to line 27, sprinkled everywhere within your program? Then you have to make changes to those thousands of lines everywhere in your program just because we changed the coordinate system of how a point is represented. Is that making any sense? That's a lot of work. Now, what if I have thousands of lines that use the approach of line 23 and line 24 throughout the entire program? Do I have to do anything? No, I don't have to do anything to those thousands of lines. I just have to change the subroutines that I have defined earlier. Set point is one subroutine, get point x, get point y are the other two subroutines. I make changes to those three subroutines, and I'm done. And I don't have to make changes to the thousands of lines that make use of those subroutines to set the coordinate of a point and to get the y and the x coordinate of a point. That is why we want to use subroutines as an abstraction mechanism to hide the details of a record. Is that making any sense? In other words, okay. This is basically the collection of all the subroutines that deal with points. I, as a user, is basically the thousands of lines to try to set the coordinate, get the x component, and get the y component of points. And this box here, that's the implementation of those three subroutines. Set point, get point x, and get point y is basically that box. I want to keep using my remote control, which is calling those subroutines regardless of what is inside that box. Okay, is that making any sense? Is the concept understood? Why we want to use subroutines to hide details inside a record? Okay, but what about efficiency? Tag, this seems like line 23 and line 24 will cost us a lot of execution time because we are going into the subroutines, setting up the parameters and all kinds of stuff like that, doing the return and whatnot. Well, most compilers are pretty smart actually. When they see something like this, subroutines that are defined like this, they will do some tricks to make it so that in execution, it is just as effective as the other one. Okay, so a lot of times, you don't lose any efficiency because of this type of abstraction. So that brings us all the way back to the name of the file. Why am I calling this ADT? ADT stands for Abstract Data Type. Okay, when you deal with abstract data type, it is a principle. It's discipline. It's a discipline of programming. It is not a language feature. It is not C versus C++. It's not a syntax. It's not anything like that. It is a discipline. The discipline is basically saying You define the record or the type of a record like this. But you only define a fixed number, a small number of subroutines, such as setPoint, getPoint, and getPoint X and getPoint Y, that are allowed to actually look into a record and say, oh, there's an A component and there's an R component to a point. You basically limit the visibility of a record to a small number of subroutines. Everybody else who want to use a point, guess what? They have to use one of these predefined subroutines. That's the approach of ADT. It's a discipline in programming. It is not a feature. There's no way the C programming language or a C compiler can enforce this. Okay? It's just a matter of discipline. When I define a record type, I only use it through a number of subroutines. So when I need to change the internal representation of the record, I only have a small number of subroutines to adjust, and everything else will work as before. Is that concept understood? Okay. So there's nothing I can do to really test your knowledge about abstract data type, because it is just an approach of doing things. It is not hard and technical, like how to evoke a subroutine, how to pass by reference, how to pass by value. This is all about just when you are designing and writing a program, how do you make your program so that it is easy to debug and also easy to maintain. This is one approach to get it done. Now ADT is a very obscure term by today's standard, because we don't use ADT anymore. Okay? Even though it's a good approach, because we have something better. What do you think that something better is? It's object-oriented programming. ADT is the precursor to object-oriented programming, or OOP. And OOP is what you learn in cisp300. You will get some taste of OOP in cisp300, but for the most part, they will actually go into object-oriented programming in cisp400. That's the class that will actually start to talk about the details of object-oriented programming. Now, is object-oriented programming something you only care about when you use C++? What about the other programming languages? What about Visual Basic? What about PHP? What about Perl? What about Python? What about just about any programming languages today? They are all capable of object orientation. So what you learn in cisp400, even though the syntax only applies to C++, the concepts will apply to just about any modern programming languages that you can use. Okay? So for that reason, I think it will benefit everyone if you take cisp300 and just take that one more step to take cisp400, because if you want to learn object-oriented programming, 400 is the class to take. The concepts still apply to most of the other programming languages. It's just that the syntax is C++ only. Okay, so that's all the time that we have for today. I hope you guys will spend the next week, preparing for the exam, for the second exam. If you have any questions, just come to my office hour or send me an email.
What's the website you use for